All right, 9.1, the composition of functions. All right, number 1 says let f of x equal negative 4x minus 1 and g of x equal x squared plus 5. Then it says find f of g of negative 3 and then find f of g, just find f of g of negative 3. Sorry, it repeats itself. All right, so let's work this out. I'm going to work this out on a different sheet of paper. So again, my two functions were f of x equals negative 4x minus 1 and g of x equals x squared plus 5. And it wants me to find f of g of negative 3. Okay, so the first thing you're going to find is whatever is in this position. Okay, because sometimes this f and g will be switched around. So whatever you do, you find this first. So I'm finding g of negative 3, which simply means to go to my g function. Wherever I see an x, I will put negative 3. So I'll have negative 3 squared, so just replace that x with negative 3, square it, plus 5. Now, be careful when you are squaring a number in your calculator. If you feel like you need to do that, you shouldn't need to do that. Negative 3 squared just means negative 3 times negative 3. Okay? But if you do square a number in your calculator, you need to make sure, if it's a negative, that you put it in parentheses before you square it. Okay, that's what gives you the positive 9. If you do not put the negative 3 in parentheses, it's going to tell you negative 9. Here's the difference. If you want to square negative 3, that's telling the calculator that you want to include the negative in part of what you're squaring. If you do not put it in parentheses, what you're telling your calculator to do is to just square the 3 and then bring over the negative. Okay, that does not include the negative in what you're squaring. So make sure you put the negative in parentheses. So negative 3 squared gives you 9. Bring down the plus 5, which gives you 14. So what we have done is satisfied this part of the problem. We have found the inner part, g of negative 3. That gave me 14. So now we find the outer part. We're going to find f of whatever your solution was here. So I'm finding f of 14, which means go to your f function this time and replace the x with the 14. So you'll have negative 4 times 14 minus 1. Well, negative 4 times 14 gives you negative 56. Bring down the minus 1 to get negative 57. So f of g of negative 3 is negative 57. Okay, number 2. All right, same kind of problem. This time f of x equals 2x plus 1 and g of x equals x squared minus 3x minus 6. This time it wants me to find g of f of 7. Okay, so again, it doesn't matter what order these are in. You always find whatever is in that position first. So I'm finding f of 7, which means to go to my f function and replace this x with a 7. So if I do that, I'll have 2 times 7 plus 1. 2 times 7 gives me 14. Bring down the plus 1, which gives me 15. So I found the f of 7, which gave me 15. So now I bring down the g, and I'm finding g of this answer. So g of 15, which means go to your g function and replace the x's. So here and here, I'm going to replace those with the 15. So I'll have 15 squared minus 3 times 15 minus 6. So 15 squared gives me 225. minus 3 times 15, which is 45, minus 6. So I have 225 minus 45 minus 6, which gives me 174. Number 3. Same thing. F of x is 4x plus 3. G of x equals x to the third. And I am finding f of g of negative 4. So again, remember, find this position first. So I'm finding g of negative 4, which means go to my g function and replace this x with negative 4. So I have negative 4 cubed, which gives me negative 64. So now I bring down this f, and I find f of whatever this answer was, which is negative 64. So if I replace this x, go to the f function and replace the x with negative 64. So I have 4 times negative 64 plus 3. So 4 times negative 64 gives me negative 256. Bring down the plus 3. Negative 256 plus 3 is negative 253. Number 4. F of x is x plus 12. G of x is x minus 12. It wants me to find f of g of x. So just like when this was a number, what did you do? You found what was in this position first, which means I am finding g of x. Well, I already know what g of x is. That is just simply x minus 12. So, and it tells you that right here. G of x equals x minus 12. So here, g of x equals x minus 12. And that's as far as I can go with that part of it. So just like the other ones, I drop down this f. And what do you find f of? Just like in the last one, you found f of whatever that answer was. So I'm doing the same thing. I'm finding f of whatever this answer was. Well, the answer just happened to be x minus 12. So I'm finding f of x minus 12, which means go to my f function, so here, and wherever I see an x, replace it with x minus 12. So first thing I see right off the bat is an x. So instead of x, I write x minus 12. Then bring down the plus 12. Well, that minus 12 plus 12 just cancels out, so I'm just left with x. Okay, now it wants me on the same problem to find g of f of x. Okay, so do you see all I did was switch around this f and g. So I am finding first off this position. So f of x equals means go to your, there's your f of x. Well, I already know what it equals. F of x equals x plus 12. So now I drop down the g, and I'm finding g of whatever that answer was. So I'm finding g of x plus 12, which means go to your g function, and wherever you see an x, replace it with x plus 12. So again, right off the bat, I see an x. So I'm going to replace it with x plus 12. So I have x plus 12 minus 12. So the plus 12 minus 12s cancel. So again, I am just left with x. So let's look here. So there's your answers. So they're both just ended up being x. Now, it also, on this same problem, wanted you, after this, to find the domain of f of g of x. So the domain of this one, so where you look is you look to see if there are any restrictions in this answer or with what you plugged in, so this part. So what is g of x? G of x is x minus 12. Well, there's no restrictions in the domain there, because remember, restrictions come into place if you have a denominator that has an x, or if you have a square root with an x under it. That's going to give you things that x cannot be, which means, are there any restrictions with the plane x? No. Are there any restriction with x minus 12? No. So the domain is negative infinity to infinity. It's also going to want you to find the domain of this part. So, same thing. You're looking, are there any restrictions with the final answer? There's not any restrictions with an x. Now, what did you plug in? What was the first thing you had? F of x. You're looking for any restrictions in the f of x function. Well, there's the f of x function. Is there anything x cannot be? No, there's not, because that x is not in a denominator and it's not under a square root. So no restrictions here and no restrictions here. Those are the two places that you look. So since there's not any restrictions in either place, again, negative infinity to positive infinity is the domain. All right, number 6. Oh, number 5, I skipped one. Okay, f of x is x plus 3. G of x is 2x squared minus 5x minus 3. So let's see, it wants me to find f of g of x. So again, let's see, what do we find first? G of x, that's the inside position. So g of x is, well again, I don't even have to solve anything. That tells me what g of x is. It's 2x squared minus 5x minus 3. So I'm done with that part. Again, drop down the f and find f of whatever answer that was. So f, because g of x is that, so if I'm finding f of g of x, I'm finding f of 2x squared minus 5x minus 3, which means go to your f of x function, and wherever you see an x, what are you going to replace it with? All of this. So right off the bat, I see an x. So instead of writing x, what do you write? This whole thing. 2x squared minus 5x minus 3. So that's what I replace the x with, and then just bring down this plus 3. And then you can put these two together because the minus 3 plus 3 cancels each other out. So here, 2x squared minus 5x is what the answer would be. Now it also, again, wants you to find the domain of this. So where do you look for restrictions? You look for restrictions in your final answer. Well, there's not any restrictions there. Again, I don't see any fractions that have x's in the denominator, and I don't see any square roots with x's underneath. So no restrictions here. Then you also look for restrictions in this part, what you plugged in. So g of x. Well, here's what g of x is, which means, are there any restrictions here? Okay, again, no restrictions in either of the spots that I need to look for. So the domain is negative infinity to positive infinity. Now it wants me to do all of it again and switch the f and g. So I'm finding g of f of x, which means find f of x first. Well, I know what f of x is. I can just look right here. F of x equals x plus 3. So now, since I have found f of x, now I find g of this answer. So g of x plus 3. Now here's the part that's going to be tedious. I'm going to my g function, which is this one, and everywhere I see an x, which is here and here, I'm going to put x plus 3. So let's see, I have 2 times x plus 3 squared minus 5 times x plus 3 minus 3. So again, I put the x plus 3's in these two spots. So before I do any distributing with this 2 or that negative 5, I'm going to do this right here, x plus 3 squared. So I bring down the 2. X plus 3 squared means x plus 3 times x plus 3. So let's FOIL this out. Again, just bring down the 2. X times x is x squared. My outer x times 3 is 3x, and my inner is another 3x. So let's just go ahead and put those two together. Outside is 3x, inside is 3x. So all together I have 6x, and then 3 times 3 is plus 9. Let's just bring the rest of this down. Minus 5 times x plus 3 minus 3. Now, let's remove these parentheses, first of all, by distributing this 2. So here I have 2x squared plus 2 times 6x is 12x plus 2 times 9 is 18. Distribute the negative 5 to get negative 5x. Negative 5 times 3 is negative 15. Bring down that minus 3. Now, let's clean this up, which means combine like terms. There's no other squareds, so let's just put 2x squared. Let's see, I could put, there's an x, a 12x, and a negative 5x. So if I put those together, that gives me a positive 7x. Now, I can also put all these terms together because they're all just plain numbers. So 18 minus 15 is 3, but then I have minus 3. So all these, when I put those together, they leave me with nothing. So I am just left with 2x squared plus 7x. Now, that's the answer to that part. Now it wants me to find the domain, which means look for restrictions in your final answer. No restrictions there. And then the part where you plugged in, which is f of x, was here's f of x. Are there any restrictions in this part of the domain? Is there anything x cannot be here? No. Since there is no restrictions in either spot, again, the domain is negative infinity to positive infinity. All right, number 6. F of x equals 9 over 1 minus 4x, and g of x equals 1 over x. This is where it gets interesting. So let's see. The first thing it wants me to do is find f of g of x. Okay, so what do I find first? I find the inside first, which is g of x. So g of x equals, I guess go over here, and it tells me right away that g of x equals 1 over x. So I'm done with the end part. Drop down the f. And what do I find f of? I find f of the g of x, or in other words, f over whatever this answer is, which is 1 over x. Which is interesting because now what does that mean to do? That means to go to your f function, which is this one, and replace the x with 1 over x. So let's see what that looks like. It's going to be a big mess. I have 9 over 1 minus 4 times. What do I replace the x with? I replace it with 1 over x. So let's see. Now I have 9 over 1 minus, when I multiply this 4 times 1 over x, you can think of it as 4 over 1, and you just go straight across on top and bottom. So that's just 4 over x. Now, here's the thing. It's not going to let you leave your answer with a fraction that contains a fraction. You can't have a fraction as part of your whole fraction or the denominator. So let's see. Whatever, to get rid of this, remember, I can multiply anything out by anything I want as long as I do it on top and bottom. So whatever this denominator is, that's what I'm trying to eliminate. I don't want to have the x in the denominator. So whatever that is, multiply the top and the bottom by that. And let's see what happens. So let's see. On top, 9 times x just gives me 9x. Over. This x goes to both of these. You distribute it. Well, what's 1 times x? 1 times x is just x. Minus, when I multiply this times x, this x just cancels that. So all I'm left with is x minus 4 in my denominator. So once again, once you get this crazy, wacky looking fraction that's got a fraction within a fraction, whatever the denominator is, just multiply the fraction on top and bottom by whatever that is. That's going to make the bottom not have that x in the denominator. Okay, so here is what the final answer is. So let's keep that one in mind. It's going to ask me to find the domain in just a minute. So now I'm done with f of g of x. The next thing it's going to want me to find is the other way around. G of f of x. Which means this time I find f of x first. So I go and I try and solve for f of x. I already know what f of x is. It tells me right here that f of x equals 9 over 1 minus 4x. So I'm done with the f of x part. So now I'll drop down the g and plug in what my answer was. I'm finding g of 9 over 1 minus 4x. Which means go to your g function, and wherever you see x, replace it with 9 over 1 minus 4x. So let's see. I will have 1 over, okay, there's my x. So there's what I'm replacing. What am I replacing it with? This right here. So 9 over 1 minus 4x. So once again, just like my last problem, I have a crazy fraction within my fraction. So what did I do to fix that on this last problem? Whatever was in the denominator, which in this case was an x, I multiplied the top and the bottom by that. Because what happened in the bottom? It canceled out that x, which is what I want to happen. So let's use that information and come over here. What is in the bottom of this fraction? Let's see, it's 1 minus 4x, which means that's simply what I'm going to multiply by. Let's see what happens. In the top, well, 1 times all of this, if you distribute a 1, it's just going to give me 1 minus 4x, right? If you multiply something times 1, it doesn't change. So I just have 1 minus 4x in the top. Now, look what happens in the bottom. That cancels that. So you're just left with 9. So you have 1 minus 4x over 9. Okay, now, here's another. Now the next part says, what is the domain of f of g of x? Which means the domain of this one. So you're looking in 2 spots for restrictions. Here, your final answer. This one does have an x in the denominator, so there is a restriction. So let's see. I need to find out what makes this denominator 0. So let's see. X minus 4 cannot equal 0. Add the 4 to both sides. So x cannot equal 4. There's one restriction. So again, you look at your final answer, and then you look at where you plugged in. So what did you plug in? G of x. Here's g of x. Are there any restrictions here? There is. Look, There's an x in the denominator. So again, I have to find what that restriction is. Whatever the denominator is, it cannot equal 0. So there's another restriction. X cannot equal 0, and x cannot equal 4. So it's two things that it cannot equal, which means if I was going to write this in interval notation, and it's a multiple choice part of this question, let's see, it can be anything on the number line except 0 and 4. So how am I going to write that? Negative infinity to 0 in union with all the numbers between 0 and 4 are okay. Again, the only numbers not okay are 0 and 4. Between them is fine. And then in union with 4 to 0. And again, it'll be multiple choice, so you'll find the one that shows that. Now, so there's the domain of f of g of x. Now, the other one, it wants me to find the domain of g of f of x, which is this one. So the two places I'm looking are my final answer. Well, look at my final answer. There's not any restrictions in this part. In order for a fraction to have a restriction, there would have to be an x in the denominator, right? That's why this one had a restriction, because there was an x in the denominator. Since there's no x in the denominator, there's no restrictions in this part, okay? But remember, the other part that you have to check is the inner part. Are there any restrictions in f of x? Well, here is f of x, which means, is there an x in the denominator? Yes, there is, which means I need to record this restriction. So I need to say 1 minus 4x cannot equal 0. Solve it for x, so subtract the 1. So negative 4x cannot equal negative 1. And then divide by negative 4. So x cannot equal, since it's a negative over a negative, it can't equal positive 1/4. So that's the only restriction, because remember, this part had no restrictions. So the only restriction is this 1/4. So x can be anything except 1/4. So from negative infinity to 1/4 in union with 1/4 to infinity. Number 7. On number 7, f of x equals 7x plus 1. G of x equals square root of x. So let's see. It wants me to find f of g of x. So let's see. Finding f of g of x, which means the first thing we need to find is the inner, which is g of x. So I know that g of x equals the square root of x. Now, drop down this f. I'm finding f of whatever that answer was. So the square root of x comes here, which means I go to my f function, so up here, and wherever I see an x, what am I going to replace it with? A square root of x. So I will have 7, replace x with square root of x, plus 1. And then that's as far as I can go with that. So there is that answer. Now, I find it the other way. It wants me to flip-flop the f and g. So g of f of x. So this time I'm going to go to my f of x function here, which means f of x is 7x plus 1 drop down my g. So now I'm finding g of whatever that answer was, so 7x plus 1, which means go to my g function, and wherever I see an x, I'm going to replace it with 7x plus 1. So I have the square root. And then under the square root, instead of writing x, what am I going to write? 7x plus 1. Now, that's as far as either one of those can go. Now, again, I'm going to find the domain of both of these. So, again, finding the domain. So, let's look for restrictions in the answer and then the restrictions of what you plugged in, which was g of x in this case. So, I'm looking for restrictions in these two spots. So, the good news is that they both have the same restriction, right? They both have a restriction right here with that square root of x, which means what's underneath this square root has to be greater than or equal to 0, because what's underneath the square root has to be positive. If it's negative underneath here, then that means you're going to have the square root of a negative number, and you can't have that. That will bring into effect the complex numbers of the i's, and we don't want to get into that. So, since they're both the same thing, I just need to make sure that x is greater than or equal to 0. And if I'm going to write that in interval notation, which is what the multiple choice questions are going to show you, is that it's not even multiple choice. You'll have to write it out. In interval notation, greater than or equal to 0, which means since it's greater than or equal to, the number has a bar around it, or a bracket, 0 to infinity. Infinities always have parentheses. All right, so the domain of this other one, g of f of x. So let's see, we're looking for restrictions in your final answer and in what you plugged in. Well, we'll look at what you plugged in. You plugged in f of x. Well, f of x is simply 7x plus 1. There's no restrictions in this part, so there's none here. I don't even have to worry about that. But since this is a radical, what's underneath here has to be greater than or equal to 0. In other words, positive. So I need to make sure that 7x plus 1 is greater than or equal to 0. So set it, just tell it exactly what you need to happen. You want this to be greater than or equal to 0. Solve it for x. So subtract the 1 from both sides. So 7x needs to be greater than or equal to negative 1. Divide by 7. So x needs to be greater than or equal to negative 1/7. So in other words, if I'm going to write that in interval notation, greater than or equal to negative 1/7 would be a bracket around negative 1/7 to infinity. All right, last one. F of x equals the square root of x plus 4, and g of x equals x squared minus 4. Finding f of g of x first, which means start off by finding g of x. Well, I know g of x equals x squared minus 4. So now drop down my f, and I'm finding f of this answer. So f of x squared minus 4, which means go to your f function, and wherever you see the x, which is right here, instead of writing x, you're going to write x squared minus 4. So when I do that, I'll have the square root underneath there. Instead of x, you'll have x squared minus 4. Bring down that plus 4. The square root of x squared. Now here, this is kind of funny. On number 8, when you take this right here, the square root of x squared is actually the absolute value of x, okay? And that is because you want to make sure that whatever's in here ends up being positive. So that just ensures when you put the absolute value bars around it, that's the only one that has the absolute value, is that right there, this answer right here. So this f of g of x ends up being the absolute value of x. Then find it the other way around. G of f of x. So the first thing I find is f of x, which is this right here, square root of x plus 4. Now, bring down my g, and I'm finding g of that answer. So g of the square root of x plus 4, which means go to my g function, which is here, and wherever I see x, I'm going to put the square root of x plus 4. So right off the bat, there's an x. So I'll replace it with the square root of x plus 4 squared. Bring down the minus 4. Now, look what happens. If you have the square root of something squared, it's like these two things cancel each other out. So I'm actually just left with x plus 4 minus 4, and the plus 4 minus 4s cancel out. So I am just left with x for that answer. Now, the second part again is I'm going to find the domain of each of these. So let's look. The domain here. Now, it's got absolute value bars around it, so that means it doesn't matter. What I'm going to plug in here, it's going to end up positive anyway because it's an absolute value around it. So there's no restrictions in what you can plug into an absolute value. So there's no restrictions here. Also, let's see, what did I plug in? I plugged in g of x. Well, here's g of x. Are there any restrictions here? Well, there is no restrictions because there is no square root and there is no denominator with an x. So there's also no restrictions here. So there is no restrictions on this domain. So negative infinity to infinity. Now, on the other one, let's look at this. I look for restrictions here. Well, the answer was just an x, so there's no restrictions here. The other place you look at is what you plugged in, which is f of x. Well, what is f of x? It's this right here. So this does have an x underneath a square root, which means there is a restriction because what needs to happen underneath here? What's underneath here needs to be greater than or equal to 0. So you need to have x plus 4 is greater than or equal to 0. Solving it for x, so subtract the 4. So x needs to be greater than or equal to negative 4. So if I'm going to write that in interval notation, again, there were no restrictions here, so I didn't have to worry about it. The restriction here is that x needs to be greater than or equal to negative 4, which simply means negative 4 to infinity.